test. Test, test, test. Okay, where the hell is the link? Ah, here we go. Alright, so I'm setting up this new RoboSub simulator. A few things have already been done here. Should probably just start from scratch. So let's start from scratch and make a directory, catkin workspace, make a source directory, and now we need to clone the repo. Let's see. So I just need to clone the cu sub repo. This should only take a moment. Alright, so once you've cloned the repo, first thing, set up the sub modules. Ah. So if you already have this cloned, Sarush recently did a removal of some large files from our repo, so you'll have to reclone it to get back in sync with everything. Alright, so we checked out the sub modules. So now we go to our catkin workspace and we just do catkin build. So you'll need ROS installed. I already got a problem. Let's see what it's complaining about. Well, that's interesting. Oh, right. Okay, so first thing, if you don't have your environment set up, I have ROS 1, 2, and a couple other things on here, so I have a very special setup. I have to source melodic, so that's my my bash RC shortcut. I'll just show you them all real quick. So you can see melodic, I'm just sourcing the setup. I also have a workspace source, which is not going to work for this. Alright, so now that that's fixed, we can build the new workspace. I believe this will take about 6 minutes. Let me... Oh, look at that. Alright, so here's one of the first problems you might come across. So you're going to need a lot of dependencies. Most important ones are going to be PID and robot localization. I already have them installed, but I'll show you them to you in a second. This is a sub-only dependency, specifically for the mini sub, since it uses the CSI cam. So all we're going to do is we're going to do a touch catkin ignore in source cu sub common drivers Jetson CSI cam. Now it is not going to build that package, and we can get past it. Yeah, you can see. Oh, okay. What did I forget? Did I misspell catkin ignore? Oh man. Computers. Oh. Oh my god, I just don't know how to use them is the problem. Alright. That's actually what I was supposed to type. Yeah, I can remove this from this folder. And now I can build it. Let's see that we get past it. It shouldn't show up in our list. Yeah, looks like we're past it. Alright, and while that's going, let me set up my workspace. I use VS Code, so I'll just show you that real quick. Where is that new folder I just made? Ah, here it is. come on. Let's see, did it? Oh, man. Try this one more time. Okay, here we go. Finally, let me move this up. Alright, so yeah, so here is basically, we'll just go over the layout of the code real quick. So there are 4 core areas. There's CU sub bring up, CU sub common, CU sub, well, okay, bring up's not one of the core ones. The core ones are these 4: common, cortex, perception, and sim. Bring up just has some sort of utility launch scripts for starting things. And honestly, we don't really use anything in here, so maybe just ignore that. Common has, most importantly, all the drivers for stuff on the sub. We got our camera drivers, we got the drivers for the controlling actuators, we got the motor controls through the Pololo, we got the IMU drivers. This is the one for the big sub, this is one for the mini sub. We got the simulated drivers, we got the DVL, and we got the depth sensor. Then in common, there's also the motor controls. So this basically is the controller matrix. Most importantly is this one. And this just starts up all the PID loops. And all the PID loops are just connected to... How are we doing? Okay. Okay, so here's another fun error. We thought we had fixed this, but we haven't. So there's something about this, the CMake, that this generated H file doesn't get built in the right order. So as soon as this build finishes, I got to restart it again. So this has been generated now. So if I run the build a second time, it'll work. But yeah, where was I? So let's look at the scripts just to give you an idea. So this is the guy, PID Pololu matrix. So this is the motor mappings, right? We're mapping our axes. So the roll axis, the pitch axis, the yaw axis, that's basically the column. And then the rows are which motor. So you can see for roll, we drive the front right and the motor forwards, and the front left motor the opposite direction. So you can see how those mappings map into roll. And then we have some little tweaks here and there to let us scale the motors, tune the PWM offsets in case there's some kind of weird issue with the ESCs, and to flip the motors, because if they're running backwards, it can be a pain to go in and manually change the bullet connectors, so we have a configurable parameter there. And all this does is it basically just integrates our strafe for us somewhere, and that might actually be in post PID. So this integrates our strafe for us. Let me see, is it? Oh my god, it's still going. What is it? It's building one of these things. Alright, where was I? Yeah, so where is the important bit? Point and shoot. So yeah, this takes our basically changes in our X and Y from the odometry and integrates them into the drive and the strafe. So that's basically all this pose PID does. And the other thing that happens is the motor mapping. So basically, we listen to the PID loops publishing the control efforts, put them into the motor array, and we send that over to the Pololo driver. So that's effectively how the sub is controlled. It's a very simple control system. Doesn't allow us to do much. We can't really, do things where, because of like the depth axis, the way it's mapped, we can't really be significantly rotated off of, a flat plane. A little bit of a limitation there. Darknet ROS is what's taking very long to build. So yeah, that's our motor controls. There's some debugging tools. So there's a joystick control in here. So this is designed to let you use like a PS4 or an Xbox controller to control the sub in the simulator or in real life. And there's some more basic teleops here. So you got teleop set points. This just lets you type in a set point. And the sub will try to meet it. So I'll show that later once we have the sim up and running. And this one's for testing the motors, basically. You give it a motor letter, so it's QWEADCXC. So all of those just map to what you'd expect. W is the forward motor, X is the back motor, A is the left motor, D is the right motor. S is just to stop all the motors. That's what that middle key does. But you type in basically that plus, you can see right here, plus an intensity, so letter, number, intensity, multiplies it by 10, adds it to the PWM. So this just lets you check all the motors to make sure that they are functioning. That's what we generally use this script for. There's some AR tracking stuff that we don't really use. It can help us estimate the sub's position for localization if we put the giant AR tag in the pool. So that's pretty much what's in common. It's basically all the drivers and just the basics of the motor control of the sub. So the cortex is where mapping and the state machine come in. I'm not going to get too deep into these because they're pretty complicated. Oh my god, Darknet takes forever to build. Alright. Yeah, so the state machine is very basic. It's based on Smatch. It uses action server calls. There's some core functionality in there. Let's see if I can find it. I think it's all in here. Tasks. Okay, so you can see each task basically has a file. Do the Jiangxi buoys, do the octagon, do the triangle buoys. So just look at the triangle one because it's fairly interesting. I'll just talk through it. So there's the three classes from Darknet that we might get the vampire detections on for that particular buoy. Alright, and so we're basically, you can see, we're looking for, in the front Occam, we're looking for these triangle buoy classes. That's the init objective, so the way this thing is designed is it's going to basically do a search. That's kind of what this setup is. So you can see we link from search to Slay, and then there's some timeouts. So here's the Slay. So once we've seen it, we start doing some visual servoing feedback. Eventually we orbit. So yeah, you'd have to really dive down into the code to fully appreciate what's going on here. But just in terms of stages, wait for visual servoing to start up. We start doing orbits, ideally assuming it's configured to do orbit, which it should be. Then where is the termination? So this is just all the initialization. Okay, now I see. So we're just setting up to orbit here in the initialization. So there should be some more core functionality somewhere in here. Oh my god. I don't even know how this works apparently. Oh, I see. So this visual servo method must be what it actually calls in the core. Let's work through this. Here we go. Okay, so the init, this is literally just pulling the server parameters for how we're going to do it. There should be an execute method in here somewhere. Okay, here we go. So we're doing the visual servo method in the execute. And this is the code that actually runs. First thing, we set up the approach visual servoing. So basically it's just pointing and driving over to the thing. Once we've driven over to the thing, we switch to doing orbiting. Once we've completed our orbit, so you can see like we have exit conditions here. Right, if we only see the vampire we're trying to get to, that's our exit condition, right? So we orbit around till he's the only one we can see because we're phasing him, then we exit. And then the final thing is we just move forwards, and then we back up. So that's basically how a task is written. And the higher level sort of configuration is, we can look at our finals config here just to give you an idea. So we got a set of tasks. First task, start gate, Jiangxi, triangle. So these names all just map to the names of the files here. But they do, in fact, if you want to add something, you do in fact have to add it to the core state machine file, which is somewhere in here. Let's see if I can find it. Is it in here? It's match top, so for some reason that's what it's called. But you can see they're imported here, and then basically we generate the tasks based on the task name. So basically what's in this mission config. And then it'll pull all its parameters from this file. So for example, we were just looking at the triangle buoy. You can see we're in orbit mode. We're going to orbit basically strafe right. Oh, let's see, is it build done? Oh my god, what the hell? I'm honestly a little concerned about how long this is taking. You know what? I'll just try starting it again. Alright, yes, our target vampire, so which one we actually want to slay. No torsos in the back, I guess, for a finals run. Or a wildcard run. Okay, this must have been the wildcard run. And then there's a bunch of specific parameters. So in this case, we wanted the class to fill 25% of the frame. That's basically how we're controlling the drive servoing. So right, we're going to move forwards until the detected bounding boxes are 25% of the frame. Then there's a timeout, right? And this one is basically, this exists because we don't have velocity controls. So our velocity control is basically we set our set point a certain distance in front of our current position, and that is effectively a velocity control that's just, basically based on how the PID loop's tuned. It's pretty terrible, but, it works. It's a hack. Yeah, and then our threshold, so this is just like how close to the center we want it. So that's basically, oh, it's failed again. What this time? Why? Okay, apparently I lied when I said that would work if I ran it again. Let's try it one more time. I don't know how I expect any of you to get this thing working if I can't get it working. Oh, you know what? I'm probably on the wrong branch. Actually, oh god, let's see. No, because I would have cloned from dev, wouldn't I? Let's see. Git branch. Git log. Yeah, I'm on develop. And the latest stuff is Sarosh's readme stuff, so that should be fine. Alright, let's try Kakin build again. Let's see if it works this time. So yeah, that's how the mission configs work, and that's how you add different tasks in the current architecture. And that's most of what's in Cortex. So the only other thing that's in Cortex is the very underutilized mapper. This is really only used for the start gate. There's some useful scripts in here, but this is the only one we're really using right now. Some of this other stuff's kind of in progress. Future integrations. Let's see, is it gonna, yeah, let's do melodic for now. Alright, so we have a moving average filter on our poses. There's also an exponential weighted average if we want to use that instead. But yeah, the core of the mapper is it listens to task poses, which is the output of basically the localizer, which I'll get to when we're in perception. But basically the localizer figures out how things are relative to the camera, and it publishes that in a detection array. So this thing takes in the detections, and based on the class, it transforms them from the camera frame into the odometry frame, averages the poses over time to get a more accurate estimate, and then republishes that as a pose in the odom frame. So then we can navigate to those poses. So that's basically what the mapper does. We see a thing, we solve its pose, it comes in the mapper averages it, republishes it for whoever needs it. So that's all that's really in the mapper. So now that we're done with that, we can move on to perception. Let's see here. Alright, so we're going to start with the multiplexer. So just a quick overview. I don't have the chart anywhere. I don't have any kind of chart that wasn't originally on a whiteboard anyway, so the camera comes in, first thing it hits is the darknet multiplexer. Pretty straightforward piece of code. Subscribes to all the images, and then in sequence republishes them to darknet. So So this way we get a post from camera 1, post from camera 2, post from camera 3. So this has some issues currently in that it's not synchronous with darknet. So ideally we want to integrate this into darknet at some point, because right now, depending on their different, frame rates, you might skip an image, you might get the same image twice. It's not great. Could definitely be better. And then that feeds into darknet ROS. So this is our copy of what's essentially just it's our fork of what's essentially another person's GitHub repo for darknet. Most of that is, let's see, are we making any progress over here? Oh my god. Okay. So, this is gonna take me a while to figure out, so I'll just keep talking through this other stuff. I have a copy of the sim that works somewhere else, so. Or do I? Yeah, I do. Right? Yeah. Okay, never mind. I do. Let's just jump over there real quick on this then. So I can't get to build. We'll work through that here in a minute. Let's see. So this is, I moved it. Let's move it back. Move this into source. Alright, so we'll pretend like my build worked. So once I figure that out again, we'll fix it. But in the meantime, this works. So I have melodic sourced. I also have to source my workspace. In my case, I just type ws and it just sources this folder, the setup.bash. So now I can access all of the things that I need. Also, I have some shortcuts here. So I'm going to use these shortcuts because I hate typing this whole thing. But I would recommend you do the same things because they're horrible. They are horrible. Alright, yeah, so we're going to need to basically, let's just get into this before I talk about perception here. So the first thing I usually do is I start a core. Oh. Next thing we need to start up is the sim. I think so in this case I will launch Transdeck, the Transdeck simulation, which, like I said, that is this. So that should be running. Let's see, is it running? We should get a gazebo window in a second here. Gazebo. So if I launch the right thing, we should have the full Transdeck simulation. So you can see we have no submarine yet. That's the next thing we're going to launch. But this was the finals run. Through the gate, hit the buoy, attempt droppers, attempt the octagon. So hopefully I'll be able to actually do that in sim here. So the next thing we're going to launch is the submarine. So in my case, that's just Leviathan. Okay, maybe not. Oh wait, I didn't source anything. Melodic, workspace, Levi. Oh wait, but that wouldn't matter because that's, what do I call it? Oh, it's description. Okay. In my case, it's description. So that's going to launch the robot description. And now we got a happy little RoboSub. But it doesn't have any controls or motors. So we're going to launch common. Alright. So those are the core pieces you have to launch. I should be able to control it now. If I do a ROS launch, you know what? That's just going to be horrible. See if I can remember what to do, because these are the only ones I have shortcuts for. Don't make my mistakes. Write everything down. Alright, so for example, if we wanted to start the state machine, let's just hope it's in my, no, it's not in my reverse search. Tragedy. Alright, so we would be doing a ROS launch, CU sub, Cortex. Oh, right, it's called Cortex. Maybe that's why it's not. Let's see if I can. Nope, definitely not there. Cortex. Oh, right. Cortex. Bring up, and then let's just see let's just show you what else in here. So there's Cortex Sim typical. Let me look at what code's actually in there before we decide what we're launching. So if you need to know what a launch file is going to do, go to the package, see sub Cortex bring up. In this case, what's in Sim typical? It's going to launch the state machine. It's going to launch the config, mission seed, config, see winning. You can see we can change this, which is very important if I want to do something, more interesting, right? If I want to use a different config. This is going to be our files config, which I think is not this one. Let me look at that real quick. So our finals config, where the hell is that? Common. Yeah, you know what? There should be a symbolic link in here somewhere, but yeah, that's not in common. It's in here. It's in the state machine. Ah, here we go. This is the actual one we want to launch. This is from the finals, and I'm pretty sure these are the parameters we want to use. Alright, so we're going to change this config file name. So let's jump over to here. We're going to do the Cortex Sim typical launch. And we're going to launch it with config file name. So this is how you pass parameters within the console. Colon equals. And we're going to do mission config finals. .yaml. Alright, there's a few more things we need to start up before this will actually be able to run. Those two things are the perception stack with fake yellow. So let's see if we can figure out how to launch that. Let's see, is that in my reverse search? No, of course it's not in the reverse search. Alright, let's just check to make 100% sure it's not in my reverse search. Let's just look at all the things I've launched. Oh my god, really? That's it? What a nightmare. Alright. Alright, so we gotta figure out what the heck we gotta launch to get the rest of this working here. So that gets a little complicated, honestly. So we need to launch a bunch of perception stuff. So we can go to the perception, bring up, and we're going to be launching perception sim. So let's just check what all this is going to do. First thing, we want fake yellow. So this really depends on how good your GPU is in your computer and if it can handle it or not. Also, how the GPU, how the net you're using is trained, right? So if you don't have a net trained on simulation data, in spite of all the real-world data it's seen, it might have a difficulty identifying the obstacles in the sim. So I don't have any of that right now. I also don't have the sim. I don't think I have the neural net config set up. So I'll have to go over that at some point. Oh my gosh. So let's start by launching out. ROS launch. CU sub. Oh my god. Oh, right. I always forget such important things. ROS launch, CU sub, perception, and we're going to launch this perception sim. And we're going to set fake YOLO to true. So we are using Leviathan. So let's just go over what all this is going to launch here. So it's going to set up all of these parameters. Some of them we aren't going to use, like this, the darknet stuff. It's going to launch nodelet. So all our perception stack's nodeleted. That's just so it can send images between nodes without having to use a TCP stack, which slows things down a lot. It's just passing pointers when you use nodelets, so much better. So we got the localizer that basically just analyzes our images and generates relative poses for them in the camera frame. Got the darknet multiplexer. That's what's going to be switching through our 7 cameras. Right now it's not using the torpedo camera, so it's only switching through 6 and it's feeding them to darknet. There's a darknet drawer. That's a debug tool to see what darknet's seeing. Um, this is to load the darknet classes into darknet. The darknet drawer, maybe? I've never actually looked at this code. I don't know what it does. Then we got the darknet nodelet. You can see, unless fake yellow. So since we set fake yellow, we're not going to use darknet. Instead, we're going to use fake yellow, and it also has a config, marginally important. But this basically just means it's going to use Gazebo's knowledge of where things are to generate fake bounding boxes. And it's going to do that without needing the GPU to run a neural network. So let's jump back over. Let's start this up. Alright. So let's jump this. Let's see. So a lot's going on here. Let's just take a quick look at our Qt. Oh, melodic. Hello. There we go. So let's just look at some of the stuff that's happening so we can look at our images. Let's scale them so we can see them. So this is what the front camera's seeing. Is there anything important here that I wanted to do? What about so in theory, if we were getting detections, they would be here. But we're not, so we don't see anything. Alright, so so what else is important? So you notice one of the things that was not set up there is perception control. So let's go over perception control. Perception control. Here we go. So this has to be launched. We're launching perception control. So hopefully there's nothing too horrifyingly important in here that I'm going to forget to run. We're not using this, but we're going to leave it alone. We're not using the optical flow. So a couple things that are in here just to talk about them since they're here. Path orient. So this is a special node that basically looks at the path in the down cam and aligns us with it. So this is for doing that path task. Optical flow tracking. This is something that chains onto darknet and takes a bounding box and then uses basically finds some points in the image, tracks those points, and basically transforms the bounding box so it's like we're still getting darknet hits, but instead we're using optical flow tracking on the image to figure out where the bounding box is. This basically fills in the gaps where darknet is just dropping the ball. And then we got our visual surveying and visual pointing. So visual surveying, that's very much controlling the axes by the error of some points in the image. So if the bounding box is a little to the left, we either control yaw or strafe to make it in the center. Visual point, this is where we don't see it in our front camera and we need to point at it. So we just look at every camera, and then when we see what we are looking for, so when darknet gets a detection, we just turn to that direction so it's in the front camera frame. Alright, and there's a config file, which I'm hoping the defaults are good. That's looks like we're all good here. So let's launch that. Alright. So once again, gotta source everything. So you can set this up by default. The only reason I don't have it by default is because I don't work on just the one thing. I'll assume a bunch of you probably also need multiple setups. That way you can, using a couple aliases, you can quickly load whatever you need in a terminal. So ROS launch, in this case, we are in CU sub perception. We are in perception control this time, so it's not one of the bring up packages. Hello? Can you autocomplete? Is it? Oh, sorry. I feel like a imbecile. Perception control directly. And I believe this one was called perception control launch. This is one where it's going to be important. You'll notice that this is not launched into the sub namespace. We have to do it manually for this one. So there is a special thing you got to put here. Basically, underscore underscore ns colon equals. This will launch this into a namespace. All right, so slight issue here. I think it only needs to be launched in the sub namespace. I don't think it needs to be launched into the package level namespace. Yeah, okay. So you can tell from here because of what these topics are. Since this is the package namespace in here, it means this definitely just gets launched into the sub namespace. So I have perception control running. Alright, I think that is all of the things that need to run for sub work. Let's find out. It's been a while since I've done this, in case you couldn't tell. So in theory, sub will start doing things. We hope. Oh my god, the sub's doing a thing. It dove. Alright, so it did the dive. So clearly it has motor control. So it's configuring cameras. Alright, so this is a point where we can bring up our QT if we want to maybe get a little diagnostic data on what the sub's thinking, separate from the state machine output. We can look at the multiplexer, for example. You can see that we're only looking at the front camera. Okay, well, there we go. Can see third leg. Oh, good, it's working. Let's see if the darknet drawer is working. I don't remember if it works with this. Yes, okay. So you can see the darknet drawer. It draws the darknet detections for debug reasons. So we're going to try and go through the right side. We'll see if it succeeds. It's kind of centered. So it's doing style points. Do 2 rotations. Now, the real sub actually spins a little faster than simulated sub. But I guess that's just what you get when you're not that great at picking hydrodynamic parameters for your model. A little more drag on the rotation than the real sub. Alright, we should be finished. So now it's going to try to go through that right side. I think it didn't get a very good post-solve. Yeah, it didn't. We may have an issue here. Yeah, okay. I'm going to have to give the imaginary sub a little help. Ideally, that doesn't really happen. But, you know, what you going to do? Okay, so it should start doing buoy soon. We're not getting detections? That's not good. Okay, sub is having a very bad day. Very bad day. What the heck is going on here? It looks like it's doing a point. Okay, is it doing Shang-Chi? Oh crap! Did something crash? Dang it! Perception crashed for some reason. All right. So, more fun information for all of you. Perception will crash for no reason. Yeah. It crashed again. That's wonderful. What happened here? Oh. Oh, okay. It's because I deleted the start gate. Well, that's my bad, guys. Alright, I have to restart the whole thing. Yeah, apparently if you delete Stargate, fake YOLO, can't figure out where it is and crashes. New information for me as well. Alright, let's fire that back up again, because why the hell not? You can see all the commands that have to be run to make a thing happen. There's gazebo. Let's get the sub back in the frame. Alright, we'll launch the motor controls. We'll launch perception stuff. Launch perception control. And we'll start the state machine back up. This time I will simply move the start gate rather than delete it. If it comes to that, hopefully it won't be that off target again. So it's doing the dive. Let's talk a little bit about the competition here. So basically how this startup task works is the sub has to float at the top and it has to stay in whatever rotation we left it. Because if it rotates at the top, you don't get random coin flip points. And that's also so it'll sit there for a little bit for the person on the dock to basically unplug the tether and let the sub move on with its life. And then once it gets down, it turns on rotation control, and we can start doing stuff. So we'll look at the darknet multiplexer. Or that no, we want to realistically. I want to look at the detection drawer. There we go. So let's see. Did we do a better job this time? Oh my gosh, we did. We're gonna make it through the start gate probably this time. Or not. Okay, what the hell is going on here? God damn it. The f***ing hell. I have no friggin' idea what's going on. Okay, so it's gonna try to go through the start gate. Apparently that was style. Oh, no, uh-oh. Alright, so... Okay, this is a write-off. This simulation is a write-off. I don't know what happened there. You know what, we're gonna fire up our Arphis on the next run, because I need to see what the hell is going on. Oh my god. Alright. Alright, the magic of Arphis. Let's use... Is this the one I normally use? I don't know. Let's find out. Alright, that's close enough. So we're going to use this as our UI. Well, we'll switch back and forth between this and Gazebo. Let's just hide that. So this is where the sub thinks it is, basically. This is the odometry frame. We're in a top-down view mode right now. Let's see, let me turn on odometry. I think that's what I want. Yeah, okay. So that arrow is just going to show us where we think we are. So I assume what happened a moment ago was, for some reason, the EKF lost its mind and kind of just, went crazy. And therefore the sub went crazy because its estimate of where it was is very, very wrong. And it's trying to go somewhere, so... Let's let's add one more image here. Let's add the darknet drawer. This way we can see what detections we're getting. Okay, yeah, some bullshit just happened again. Like, look at this, what happened here? Oh god, I don't know what's happening. I'm just having a very bad day, clearly. Yeah, you can see, like, EKF is just going completely bonkers. It's weird. It didn't happen the first run, but now it just keeps. What is this? What even is this? I mean, at least the Z plane localizer works. Look at that. We know where those things are. Maybe. Fucking EKF. It's weird. It's like right off the bat. Right off the bat, it just like totally didn't have any idea where. I don't even. Is the sub even on here anymore? Yeah, okay, we're gonna have to restart again. I'll just save this and don't have to rejigger the config again. Alright, I have no idea what happened, so we're just gonna try again. This is what you do, you just try again. Yeah. This is how it is a comp, right? You know, launch the sub, it doesn't work, we just launch it again. Yes, fortunately, in the real world, I have never seen the EKF lose its mind that terribly. Maybe we'll just like slow the rate at which we're launching things, you know, give them a chance to settle down. Because we had like common running for like a while last run before we started doing things. Now, yeah, here's another one of the stupid bugs we have. Like, why is the sub on the floor? Because it thinks it's like 1,000,000 feet in the air, because the EKF is so friggin' confused. Let's just start this back up. Let's see, can we tell? Let's, panels, views. Let's change to the orbit view. Yeah, you notice how let's see, is the sub? The sub knows where it is. Oh, there, okay, I figured it out. Yeah, I just figured it out just as we came to go check it out. It's like, oh, he's watching me. He's watching me, I gotta behave. Oh, friggin'. Turn back on that. This should. Alright. Alright, we're going to try the state machine again. And watch very carefully for the exact moment when everything breaks. The moment will come. Well, at least it probably won't happen if I'm watching it closely enough. It never wants me to catch on to what's wrong. So we dove. I'm going to sit here for a little bit, then we should turn towards the start gate. Okay, it's executing the search. It's turning towards the start gate. Okay, no discontinuities yet. We're gonna start moving forwards here any second now. Alright, we sent a goal to the waypoint navigator. Alright, it hasn't glitched out yet. We're getting hits on the path marker. So let's see, is it showing out? Look at that. Look at that Z-plane localizer. Even works in the front camera. Like, we can see how accurate it was in the front camera here in a sec. Oh god, no, it's confused. What are you doing? Why are you doing this? Uh, oh my god. uh, Would you believe me if I told you this worked in the past? What the fucking is going at this thing? It's like that. Okay, you know what? Let's just let's just do some debugging. You know, why the hell not? I think it's let's see if we can't figure anything out here. Like, is the DVL not working or something? Like, what is going on? Ah, yes. So this is what our sub's brain looks like. Oh my god, this is such a fucking nightmare. Alright, okay, I am looking for something related to the DVL. It's gonna be coming out of Gazebo. Yeah, here we go. DVL twist. So here's our simulated Gazebo DVL. And that publishes to here. So this is supposed to be feeding into the EKF somewhere. Oh my god, where does this line go? Oh my god, I'm never gonna find this. It's hopeless. This is hopeless. This is hopeless. Can I? Let's see. Did I like typo or something? Alright, I guess I don't really know how to use this thing. Let's just like poke around a little bit. I may have to do this manually because I can't find anything. The power of the standalone nodelet. Oh my god, I hate that so much. Somewhere in here there is an EKF. In theory, like the IMU repub should point to it. The Gazebo depth sensor should point to it. Is this it? No, let's pose PID. Oh my god. Fake YOLO's in here. Yeah, we're just gonna, this is clearly hopeless, so we're gonna try a different approach. How about a Ross node list grep EKF. Ross node info. So let's look at the EKF's info. Should be subscribing to the DVL. Alright, let's see here. DVL. Let's just make sure there's actually data coming out of this thing. I mean, there has to be, right? Otherwise, yeah. So like, there's some perfectly reasonable values. Yeah, if the EKF suddenly stops working, it's extremely hard to debug. Like, realistically, if everything's connected to it and the data it's getting makes sense and it's just not working, It's like there's not a lot you can do. It seems like it always works in real life though. Like there must just be something about the simulated data that just rubs it the wrong way. I mean, my best guess is it realizes it's in the matrix and decides it does not want to behave. I'm gonna try this one more time, and then I'm just giving up for the day because it's been 55 minutes now. That should be fine. Alright, let's just see if it loses its mind again. So, yeah, this is a timeout to plug or unplug the wire. There we go. We're diving. Wait a few seconds, then we should turn towards the start gate. Alright, we turn towards the start gate. We're going to start moving forwards. Okay, no glitching yet. Seems like it glitches as soon as it sees the gate and starts to turn towards it. I would very much like to see this work. Okay. Don't do it. No, don't. Oh, thank God. Okay. Alright, so let's see how much this moves. I'll just leave my mouse over it. We should start seeing it in the down cam and it'll relocalize. Oh, it's not looking in the down cam for hits. That's what. Okay. Well, I guess that we won't get to see how accurate it is. Pretty close. I mean, this is. Why? Oh, the grid's not big enough. So that's a meter. So it's 2 meters, 3 meters away from our current position. It's not really centered here, right? It's behind us a few meters. So that looks reasonable. The Z-plane localizer looks like it's doing a pretty good job. Alright, that's one spin. Okay, this time, we just lift the gate out of the way if it becomes a problem. Okay, alright, we'll be prepared. Okay. Oops. Click on the gate. Okay. I'm gonna just zoop it right out of the way. I think it's gonna make it. Oh, made it. Okay. Didn't need my help. Just a little trigger happy here. Alright. Okay, yeah, so it's the other path marker in the front view. So this is one of our annoyances, right? We don't have a way for the mapper to know that there's 2 separate path markers right now. So it's another software thing we gotta work on. So it is servoing off of Jiangxi now. You can see there's clearly some not insignificant issue in the front cam when you're using the Z-plane localizer. It's mostly meant for the bottom cam. So like it shifted from here to here. But I think, pretty sure it gets more accurate the closer we get. So, we'd probably have to employ some kind of uncertainty measurement given front camera. Because like it shifted a good few meters. So obviously, if we see it in the front camera, our uncertainty is pretty high. Alright, so that was slaying of the Jiangxi. If you couldn't tell, he's dead now. He's been killed. Alright, well, since everything seems to be running smoothly, let's see if I can get both of these in the same space here. Ugh. Alright, so now visual point is going to start running. Oh, wait. Oh, okay, we did just slay Jiangxi. I was a little early on that one. This is slaying Jiangxi. So we were just centering on him before, and basically the visual servoing, the dry visual servoing just wasn't working that great. So it got a little closer than it should have. Alright, so the visual point just happened, and it sees the triangular buoy, and it pointed towards the triangular buoy, so now we're going to go do an orbit and strike the target vampire, which in this case, I believe is stronger. So up until this point, so far, this has gone as well as our finals run. Let's see if it does better on droppers. So yeah, we get up close, and then we start orbiting. Yep, we're doing the strafe orbit. We're going to wait until the only vampire we see is stronger, so we can see we're getting hits with both. So that's another issue, probably something we need to think about. The possibility that we only get a hit on Draugr while we're halfway between them. So the way that code works, we went over a little bit, but basically, once the exit criteria for the orbit servo is reached, it just keeps going for a second, and then it moves in for the kill. It doesn't do any kind of recentering. That's why we're going to kind of hit on the corner. So this is exactly what happened in the finals run too. So, it's always nice when the simulator does the same thing as the real sub. Oh my god. Okay, good. I was going to be a little annoyed if the sub got stuck in the buoy, but it didn't. So we can all relax. Alright, so on our finals run, we had a little glitch in that we saw this out of the corner of our down cam, and then by the time we switched states, it had drifted just outside. That will not happen in the simulator, not unless you really shenanigan it and move it like out of the way at the last second. It's very hard to set it up to miss. So we should succeed. Let's see. I believe the last time I used this, I was attempting to get it to just barely see it, but I'm pretty sure it'll figure it out in this run. Let's see. We're moving pretty slow. Normally we see it in the front camera too. That's interesting. Okay, so yeah, there we go. We're picking it up. So now we should servo over it. Yep, we're servoing over it. So we're going to try to servo over the wolf. That's the one that's open right now. So we should drop down and drop in the box. Oh god, what happened? Alright, there we go. Alright, let's see. Are we going to do it? Are we going to make it? Looks like we're a little bit forward. Come on, visual servo. I trusted you. Get us those points. Get us the points, visual servo. Come on, you're so close. Oh, 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 points. If we just been a little bit closer, we totally would have beat ASU. Third place. Could have gotten those $3,000. Alright, so now we should be doing the octagon. So here you're going to see another kind of buggy issue we have. Basically, I added some more fake yellow degradation since competition, and it's going to show you some more real-world behavior of the sub, as opposed to what happened in the sim when fake yellow was absolutely flawless in every possible way. So now we're going over to the octagon. We're going to center over these two boxes. Okay, so you can see we're picking up one box, which means we're going to serve over that one box. Alright, there we go. Now we're seeing two boxes. So this is the problem with real world data. You don't always get both boxes in every frame. So since there's some yellow degradation, we're going to see when it only gets one of the boxes, causes the visual servo to glitch in one direction. I haven't been keeping track of this, so here's where we are now. Yeah, you can see, look at that Z-plane localizer. I love it. Look at those beautiful poses on the droppers. And we should be getting, yeah, you can see, I can't decide which box. Where's the box? So he knows they're behind it, right? Like, it's like, I know they're back there somewhere. Yeah, because of the averaging in the back, happening in the back end, with the median filter, it's just like, it's interesting. I wonder if it's using the median filter, because you can see, sometimes it's right in the center, and sometimes it's here, and sometimes it's here. So I'm pretty sure this is exactly between the two boxes. That'll be actually a little interesting to find out. Yeah. Looks like that is exactly in the center. I didn't think the median filter could do that, because that would require some kind of averaging of the two boxes. Ha. Interesting. Yeah, it looks like basically, we're doing it. We're rising. We're rising. Oh my God, we got the points. We beat ASU. We beat them. We beat them with CV. No, not really. We just dream about beating them. Alright, so yeah, that's the finals run. So if you can get the code to build, and you can get everything to run, you can do this, and you can maybe start playing with things, developing, figuring out how the code's structured. If you're running into any issues, I'm on the Slack. I'll see what I can do. If you guys want to, like, I don't know, screen share, Google Hangouts, debugging, I can make that happen too most of the time. So, for all the new people, if you're actually watching this at any point, hit me up on Slack and we'll get the sim working on your computers. Alright, I am going to sign off now.